Okay, so for number 5, we need to find all the roots of this polynomial given one of our roots is -3 plus I. And this one most definitely got a lot of us, to say the least. So let's see if we can clear up any confusion on this guy here. Okay, well, first of all, we have to pull from our knowledge of complex roots. We know that complex roots always come in pairs, meaning if one of my roots is -3 plus I, then that means I have to have another accompanied complex root. And the sign that changes is going to be the sign in front of the I. So that means we have another root, which is -3 minus I. Okay? So really, we know 2 roots already that are part of this guy. And so really, all we have to find is just get one. Okay? So I know it sounds like, okay, we'll just get the last root. That's easy. Well, it's a little harder than just saying, well, okay, let's just get the last root, because I know that there's 3. It's quite the lengthy process. I would probably assume that there's more than one way to do this, but I'm going to take this approach, which is I'm going to go ahead and make 2 linear factors. Okay, so we know that one of our linear factors is x, and then we have right here minus -3 plus I, and then we have the other one, x minus -3 minus I. Okay, so all I did was I took my 2 roots and I made them linear factors, right? So there's nothing new there. This is what we do always. If I had a root of x equals 4, oh, well, then that means I have x minus 4 as my root. Okay, so let's multiply this out right here. Okay, and I'm going to go ahead and first distribute that negative sign. So x plus 3 minus I, x plus 3 plus I. And the trick here is to notice that we actually, if I were to just put the x plus 3 in brackets and the x plus 3 in brackets, think of x plus 3 and x plus 3. See how they're both the same, x plus 3, x plus 3? So think of that as like our a. And then we have minus I and I, so I and I. So like think of this a minus b and then a plus b. Well, if you multiply a minus b times a plus b, isn't that just a squared minus b squared? It's a difference of squares, right? I mean that's what we have right here. So let's use that knowledge and let's just square x plus 3 and let's just square I. That's what I'm going to do here. I'm going to square my a. My a is x plus 3, so I'm going to do x plus 3 squared. Okay, so I'm going to square this, and then minus my b, which is my I, minus I squared. Okay, and so that's what all this is multiplied. If I multiply it all out, I'm going to get this. Expand x plus 3 squared. So x squared plus 6x plus 9. I squared. Okay, so come up here. Well, I is the square root of -1. So if I square I, well, that's the same thing as squaring a square root of -1. Well, those are opposite, so that's why it's just -1. So it's right here. This is going to be minus a -1, which is now ultimately right there. So this polynomial, or this quadratic, will give us these 2 roots. Okay, so basically I just went backwards. If I know the roots, then that means I can figure out what the polynomial is. Okay, so I did all that work so that now I can do this. I can use long division and divide this guy into here. Because whatever my remainder is, or basically whatever my quotient is, that's going to give me my last roots. Let's think about this. We already know what the remainder is. If I know that these 2 guys are roots of this polynomial, and this polynomial is a result of these 2 roots, then I already know that I'm going to get a remainder of 0. So that means all I'm looking for is just the quotient. Okay? So let's see if I can fit this in here. Kind of, I probably should have maybe left myself a little more room here, but we'll do what we got to do. So let's do x squared plus 6x plus 10. And we're going to divide that into this long tamale. 4x to the power of 3 plus 23x to the power of 2 plus 34x minus 10. Okay. So let's go to town and see what we can do. So x squared times what is going to give us 4x to the power of 3. Well, looks like it's going to be a 4x, right? So I'm going to go ahead and put a 4x over here. And then notice that my x term goes above my x term. Okay, so x squared times 4x squared is 4x cubed. 4x times positive 6x is a 24x squared. 4x times positive 10 is a positive 40x. Okay. I'm going to go ahead and change all the signs. So that becomes a minus, and that becomes a minus, and that becomes a minus right there. So those cross out. That becomes a negative x squared. And this right here becomes a negative 6x. And I'm going to bring down my negative 10. Okay, let's keep going on here. Change back to my color. Okay, so now let's see. X squared times what gives us negative x squared? Well, negative 1, right? Okay, so negative 1 times x squared is a negative x squared. Negative 1 times positive 6 is a negative 6x. And negative 1 times a positive 10 is a negative 10. And obviously, if I change all the signs, my remainder then is going to be 0, as we already said. And this right here would be our last factor, right? So this right here is our third root. First roots, second roots. This would give us our last root. So 4x minus 1 equals 0. Add 1. And then I divide by 4. So super crunchy to say the least. But make sure that you review the study guide because I assigned a few problems on this from your assigned problems so that you get more practice before you retake the exam there. Okay. Okay, let's just go on now to the next one for problem number 6. So I'm going to factor the polynomial knowing that x equals 2, which means that we have a factor of x minus 2, correct? Now, we could do what we just did right now, which is use long division. But since this is a very nice number, meaning it's not, this is a linear factor. When you have a linear factor, then you can use synthetic division. Okay, so that's what I'm going to do right now. I'm going to go ahead and just divide 2 into this whole thing. And I already know my remainder is going to be 0, but I just want to do that so that sometimes I can get this chopped down to maybe a power of 2, and then I can factor that. So 2, negative 15, 27, and negative 10. All right, so I'll bring down the 2, multiply, get 4. Add those together, negative 11. Multiply that, negative 22. And then I get 5. Multiply, I get 10. I get 0. Cool. So that means my new polynomial is 2x squared minus 11x plus 5. Okay, so this whole thing, if you multiply by our factor right here, x minus 2, these two will give us back our original polynomial. Okay, so let's keep going here. That wouldn't give you enough credit because we can keep factoring this. And this now just becomes what you learned back in Algebra 2. So I'm going to drop down the x minus 2. But let's see. If I'm going to factor this guy, my first 2 terms must give me 2x squared. So 2x and x gives me 2x squared. And then I want to get a 5 right here. So it's going to have to be 5 and 1. So I'm going to do 1 and 5. And let's see, I want negative 11. So I suppose at least one of them has to be negative. Actually, both do because I want that to be a positive 5. So let's see if that works. 2x squared, that gives us a negative 10x minus 1x, which is our negative 11x, and negative 1 times negative 5 is our positive 5. So there would be our 3 factors right there.